Hi there. This interview simulation focuses on Git, GitOps, and real-world deployment flows. The goal is to test how you think about version control, environments, and the relationship between code, configuration, and automation. Before you listen to each answer, pause the video and say your response out loud as if you were in a real interview. That is the best way to build confidence and speed. If you want more long-form DevOps interview simulations like this, subscribe so you do not miss the next one. Let's begin with a few warm-up questions. Tell me about a time when a Git workflow decision caused problems for your team. A strong answer would sound like this. We once adopted a branching strategy that looked clean on paper, but created a lot of merge conflicts. Long-lived feature branches drifted away from main, and pull requests took days to resolve. I helped move the team towards smaller, more frequent merges, and better use of feature flags. It changed the culture from heavy merges to continuous integration, and it reduced conflict frequency significantly. Next question. Describe a situation where GitOps improved or complicated your deployment process. A solid response would be, GitOps brought consistency and transparency, but it also forced us to rethink how we manage secrets, drift, and rollback. Early on, we had a case where engineers applied changes directly in the cluster instead of going through Git, and GitOps kept reverting their changes. That incident helped us reinforce the rule that Git is the single source of truth. Once the team adapted, deployments became far more predictable. Another question. Tell me about a time you had to debug a bad deployment that originated from a Git mistake. A good answer might be, we had a developer accidentally push to the main branch without opening a pull request. The pipeline deployed instantly and the change caused failures. We rolled back, protected the branch with required reviews, and improved our commit checks. That experience reminded me that Git hygiene is not optional in a production environment. Next question. How do you handle disagreements about branching strategies or release processes? A strong response would be, I focus on the actual workflow pain points rather than personal preferences. I ask what problems we are trying to solve. Is it speed, stability, traceability, or compliance? Branching decisions should reflect the needs of the business, not just what makes sense in theory. When everyone sees the problem clearly, it is easier to agree on a direction. One more. Tell me about a lesson you learned early in your career about version control. A solid answer would be, I learned that good Git practices prevent emergencies more than any monitoring system. Small commits, clear messages, feature flags, and clean histories save hours of debugging. Version control is not just about code storage. It is about communication and safety. Let's move into the first half of the technical section. What is the real purpose of Git in a modern DevOps workflow? A strong answer would be, Git is the source of truth for both code and configuration. It provides history, accountability, and a stable foundation for automation. Git is not just a repository, it is the control layer for how software changes flow into environments. Next scenario. A pull request has been waiting for review for 2 days, blocking a release. How do you approach the situation? A thoughtful answer would be, I first check whether the pull request is too large or unclear. Large changes scare reviewers and slow everything down. If that is the case, I help break it into smaller parts. If the pull request is reasonable, I check whether reviewers are overloaded or if ownership is unclear. Sometimes the process needs adjustment, like rotating review duties or setting expectations for response times. Next question. Your GitOps controller keeps attempting to revert changes made directly in production. How do you handle that? A strong answer would be, I respect Git as the authoritative source. I investigate why changes were applied directly in production, whether it was an emergency or a workflow misunderstanding. Then I pull the actual desired state into Git, commit it, and let GitOps reconcile it cleanly. Afterward, I reinforce the rule that all changes start in Git unless there is a documented break-glass procedure. Another scenario. You perform a deployment through GitOps and it appears successful, but the application is unhealthy. What do you look at first? A solid response would be, I check whether the manifests in Git match the intended configuration and whether the pipeline produced the correct image. Then I look at readiness probes, secrets, and any environment-specific overrides. GitOps ensures consistency, but it cannot validate business logic or application health, so the issue may be in configuration rather than the GitOps flow. Next question. A merge conflict appears during a release branch creation. How do you decide whether to resolve it quickly or stop and investigate deeper? A strong answer would be, if the conflict involves critical code paths or configuration files, I slow down and understand the intent of both changes. Quick conflict resolution can hide subtle logic issues. If it is a simple formatting conflict or unrelated code, resolving it quickly is fine. The key is balancing speed and correctness based on the area of impact. Another scenario. Imagine your GitOps controller is failing to apply changes because of a drift in the cluster. Someone made a direct fix during an outage, and now GitOps refuses to reconcile cleanly. How do you approach the situation? A strong answer would be, I start by identifying exactly what changed in the cluster that is not reflected in Git. GitOps does not like surprises, so the goal is to align reality with the desired state. I pull the live manifests, compare them with Git, and decide whether the live state or the Git state represents the truth. If the in-cluster fix is something we want to keep, I update Git to reflect it and let the controller reconcile. If the change was a temporary hack, I remove it and allow Git to restore the declared state. The key is to restore consistency, because GitOps cannot operate when drift is unmanaged. Next scenario. Your team wants to adopt a trunk-based development model, but deployments happen through GitOps. Multiple developers merge small changes daily. How do you keep deployments safe? A thoughtful answer would be, trunk-based development can be very safe with GitOps, but only if you avoid coupling merges directly to production rollouts. I introduce feature flags, environment-specific branches, or promotion-based GitOps, where changes move across environments through controlled merges. The idea is to maintain high velocity in Git without letting every small commit instantly land in production. The trade-off is between speed and control, and GitOps lets you tune that balance with your branching and promotion strategy. Next scenario. Two different teams manage different parts of the deployment manifests. One team updates application code, and the other maintains infrastructure settings like limits and probes. During a deployment, a merge conflict breaks the pipeline. How do you prevent this happening again? A strong answer would be, this signals a structural issue in how the repo is organized. I look at splitting manifests into clear ownership boundaries, using customized layers, or maintaining separate repositories for application configuration and platform configuration. The goal is to reduce collision points. If conflicts are unavoidable, I set up automation that validates merges and provides early warnings. Collaboration is important, but so is preventing teams from blocking each other at critical moments. Next scenario. You perform a deployment with GitOps, and everything looks correct in Git, but the cluster is running an older version of the application. What do you check? A solid response would be, I first check the GitOps controller itself. It might not have permission to update certain resources, or it may be stuck on a failed reconciliation loop. Then I inspect whether an operator, admission controller, or another automated system overwrote the desired state. In some environments, multiple controllers fight for ownership, and the GitOps tool loses. The core principle of GitOps is that one system owns the desired state, so I make sure there are no competing sources of truth. Next question. You are migrating a legacy deployment process into GitOps. The team is nervous because they are used to manual control and fear unexpected automation. How do you approach the transition? A strong answer would be, I avoid flipping the switch all at once. I begin by making Git the source of truth for non-critical environments, letting the team get used to the flow. I also introduce visibility tools that show exactly what the controller will do before it applies changes. When teams feel they can predict the system, they trust it. The migration is as much a cultural change as a technical one. Final scenario for this section. You notice that your deployment repository holds both application manifests and pipeline configuration. During a failure, it becomes difficult to understand whether a change broke the app or the pipeline. How do you untangle that? A mature answer would be, I separate the layers of responsibility. Application manifests, environment definitions, and pipeline logic should not live in the same place. I create dedicated repos or distinct folders with clear ownership. This reduces cognitive load during debugging and ensures that pipeline failures do not get mixed with application failures. Separation of concerns makes root cause analysis faster and reduces accidental breakage. Let's move into the final section. These scenarios are intentionally ambiguous and meant to test how you think when Git, GitOps, and deployment automation create pressure in real production environments. Here is the first scenario. Your GitOps system has applied a broken configuration to production. The team wants to hotfix the issue directly in the cluster to bring the service back up. Others insist you should only fix it through Git, even if that takes longer. What do? A strong answer would sound like this. I focus on stabilizing users first. If the outage is severe and the fastest path is a direct fix in the cluster, I am willing to use a break glass procedure, but I document exactly what was changed and why. As soon as the system is stable, I bring Git back into alignment by committing the fix and letting GitOps resume control. The key is minimizing user impact without allowing long-term drift between Git and the cluster. Next scenario. Your deployment flow merges changes to main automatically and GitOps deploys them. A developer accidentally commits experimental code and the pipeline picks it up instantly. Rollback works, but leadership wants assurance this will never happen again. How do you respond? A thoughtful answer would be, I explain that automation reflects process design, not developer mistakes. The solution is to add guardrails such as branch protections, required reviews, commit checks, and promotion pipelines, where code moves to production only after passing through controlled environments. I also recommend feature flags so experimental work never reaches production unintentionally. Security and safety should never rely on perfect human behavior. Next scenario. You have a failing deployment, and half the team believes the issue is a merge gone wrong, while the other half believes the GitOps controller is malfunctioning. Time is tight and logs are noisy. How do you decide where to focus? A strong answer would be, I avoid guessing and focus on evidence. I check whether the Git history shows unexpected merges or conflicting changes. If everything looks clean there, I check the controller logs to see whether it tried to apply something invalid or lost permission. I start with the question that can be answered fastest, then move to deeper investigation. Under pressure, I prioritize clarity and remove uncertainty step by step, rather than jumping to conclusions. Another scenario. Two deployment tools are fighting over the same resources. GitOps is trying to apply one configuration, while a legacy operator keeps reverting it. Production is unstable. How do you break the deadlock? A solid answer would be, I disable one system temporarily so only one tool is controlling the resources. Usually, GitOps wins because it represents the declared state. Once stability returns, I remove or reconfigure the legacy operator so it no longer owns those resources. Running two sources of truth is dangerous, so the long-term fix is to ensure clear ownership and prevent overlapping automation. Final pressure question. Your production deployment flow is built on GitOps. During an incident, you need to deploy an emergency patch, but the GitOps controller is lagging by several minutes. The team suggests bypassing GitOps entirely. How do you make the call? A mature answer would be, I weigh the risk of delay against the risk of bypassing the system. If user impact is severe and waiting for GitOps will meaningfully prolong the outage, I deploy the patch manually using a controlled break glass approach. But I also prepare to reconcile Git afterward, because temporary bypasses become dangerous if they linger. If the delay is small or partial, I would rather improve the controller latency than step outside the model. The decision comes down to protecting users while maintaining long-term consistency. Before we wrap up, take a moment to reflect on this interview. Git and GitOps are powerful tools, but they only work smoothly when culture, process, and automation align. Many of the hardest problems come from unclear ownership, drift between reality and Git, or pressure to bypass the system during outages. Think about which scenario challenged you the most. Was it break-glass decisions, conflicting tools, bad merges, or production pressure? Let me know in the comments which one made you think the hardest. And if you want more long-form DevOps interview simulations like this, subscribe so you do not miss the next one.